Today we are going to look at section 4.3 on right triangle trig. A lot of this is going to be review of geometry today, so hopefully it'll be a nice lesson for you. And again, I'm at lunch today and tomorrow, so it's going to probably catch us with a bell unless I'm good enough to stop it, and I don't think that's the case. So I apologize in advance. But let's go ahead and start off by just reviewing again SOHCAHTOA. And remember, this is important because it tells us the sine function is defined as the opposite over the hypotenuse. The cosine function is defined as adjacent over hypotenuse. And the tangent function is defined as opposite over adjacent. Now that we know this, can you generate that the cosecant function would be, well, the cosecant is the reciprocal function of sine, so he's the hypotenuse over the opposite. My secant is the reciprocal function of cosine, so he is, ooh, that's a H, hypotenuse over adjacent. And cotangent would be the reciprocal, adjacent over opposite. Alright, so knowing that, let's just go ahead and get into our first example. And I'm going to ask you to find C and then the 6 trig functions. So, we've got a nice little right triangle here. 6, 8. Theta will be here in the corner, and this is C. Alright, so the first thing I need to do is figure out, well, how in the world are we going to find C? Well, it's a right triangle, correct? And I'm looking for a missing side. Hope you remember Pythagorean theorem, c squared equals a squared plus b squared. So c squared equals 6 squared plus 8 squared. So 36 plus 64 is 100, and the square root of 100 is 10. Again, I understand that I've been really getting on you guys that it's plus or minus 10. And I agree, it is plus or minus, not square root of 10, it's plus or minus 10, but remember, for side lengths, they have to be positive. So even though we have both roots, we only accept the positive. Okay? Alright, so I'm going to write the SOHCAHTOA here. I almost slipped. Haha, did you guys catch that? That's right, it's our little secret. Alright, here we go. So first thing I want is the sine of theta. So go up to your picture, and I want you to go ahead and label. So if you are standing at theta, what side is directly opposite you? So directly opposite theta is 6. Put a little O. Now go to your right angle. Directly opposite your right angle is the hypotenuse. Put a little H. And that means that 8 by process elimination is the A. Alright, so let's go ahead. So we know sine is O over H. So it's going to be 6 over 10. And we always reduce our fractions, so I get 3/5. Let's do the cosine of theta. So I know cosine is A and H. So A is 8. H is 10, and I reduce to 4/5. And last, I'd like, oh, I'm sorry, my microphone's like way over here. I hope it's been okay. Now I want the tangent of theta. So I know tangent is O and A, so 6 and 8, which reduces to 3/4. Now let's go ahead and give the reciprocal functions. So the reciprocal of the cosine function is the cosecant function. And what I want to do is take the reciprocal of the sine. So the cosecant would be 5 over 3. My secant would be, the reciprocal of 4/5 is 5/4. And finally my cotangent, he should have a little theta, sorry, would be 4/3. Okay? Any questions? If you have any, make some notes out into the margin so we can address them tomorrow. Alright, let's look at a second one, and this time I'm going to go ahead, it's going to be just a little bit more difficult as far as the math goes. So that triangle worked out nice and pretty. What happens when they don't? So again, I have my little right triangle. My theta is in a corner. This is 1 and 5. So first thing we're going to do is find C, and then we're going to go ahead and find all our other trig functions. Alright, so again, it's Pythagorean theorem, c squared equals a squared plus b squared. This time, C, remember, represents your hypotenuse. My hypotenuse is 5. So 5 squared equals 1 squared plus c squared. Alright, so 25 equals 1 plus c squared. 24 equals c squared, so c is the square root of 24. Again, I understand it's plus or minus. I know I'm dealing with a side length, so I'm okay just to put square root of 24. What should you do now? I'm hoping you know to come over here to the side and break 24 down. So 2 and 12, 2 and 6, 2 and 3. So the radical says, as long as you have a partner, you may leave. So this pair of 2's may leave, and unfortunately the 2 and the 3 singletons get to stay home. So I get that this side is 2 square roots of 6. Okay? Alright, I want sine of theta. So I go back up to my picture. I'm starting at theta. Directly opposite me is 1. My hypotenuse is 5, and that means this is my adjacent side. Okay, if you need to, write your little memory device. So sine is O and H, so 1/5. Now if you want to, you can go ahead and get his reciprocal function at the same time. So I know that the cosecant will be the reciprocal, and it will be 5. Alright, let's look at cosine. Cosine of theta is A and H. So A is 2 square roots of 6 over 5. Now that is okay because the radical is in the numerator. Radicals can be in the numerator. It's when I look at the secant that I'm going to have issues. Because my secant is going to be 5 over 2 square roots of 6. But remember, we cannot leave a square root of 6 in the denominator, so we're going to go ahead and rationalize it. So I get 5 square roots of 6 over square root of 6 times square root of 6 is 6 times 2 is 12. Alright, and I'm going to pause for a minute and go ahead and let you see if you can get the tangent of theta as well as the cotangent of theta, and make sure that you go ahead and reduce as you guys need to. My computer just popped up something weird, but it's good to go. Hopefully it didn't show up in the video. If so, excuse the pop-ups as well. Alright, were you able to get, so tangent was O and A, were you able to get 1 over 2 square roots of 6? But we know you can't leave that radical in the denominator, so let's clean it up, and I get the square root of 6 over 12. Now, you have options here. One option is to go ahead and do the reciprocal function. Okay? May I make a recommendation that you do it from the original so that you don't have to rationalize again. So it will just be 2 square roots of 6 over 1. Okay, what I need you guys to do right now is go ahead and get your wagon wheel, that paper that we've been doing in class, and let's use that to help us with what we're getting ready to do now. Okay, so I've got mine handy. We're going to evaluate each expression. So number 1, I want the cosecant of 45 degrees. So I know that the cosecant of 45, so what I need to do is find my 45 degrees. Cosecant is the reciprocal function of sine. So 45 degrees, sine is square root of 2 over 2. However, I'm dealing with the reciprocal function, so it would be 2 over the square root of 2. But once again, you can't leave that with a radical in the denominator, so let's clean it up. So I get 2 square roots of 2 over 2, and now these cross out and I get the square root of 2. Alright, let's try another one. How about if I want the tangent of 60 degrees? Go to your chart, find your 60 degrees. I want tangent, so 60 degrees, tangent, square root of 3. So my answer is square root of 3. Alright, number 3. Let's find the sine of pi over 3. So go to your chart, find pi over 3. So pi over 3, sine, square root of 3 over 2. And finally, you try to get me the secant of pi over 6. Alright, so pi over 6, and we're dealing with secant, which is the reciprocal of the cosine, so it's going to be 2 over the square root of 3. Let's clean this up, and you get 2 square roots of 3 over 3. Alright, so far so good. Okay, next thing I want to talk to you about is something called a cofunction. If you have a triangle and say this is theta, how would you define this angle up here if I wanted it in terms of theta? Well, so for right now, let's just say that this is y. Do you agree that theta plus y plus 90 equals 180 degrees? So now if I want to solve for y, I have theta plus y is equal to 90. I just move this 90 to the other side. And again, I want y by itself, so y is equal to 90 minus theta. So this corner of our triangle is 90 minus theta. So I can say the sine of an angle, theta, is the same as the cosine of 90 minus theta. Now, I want to show you why that works. If opposite theta is, let's look at theta for a minute. This is my O, my H, my A. So if I want the sine of theta is O over H. What's the cosine? If I'm up here at 90 minus theta, isn't my cosine adjacent over hypotenuse? So it's the same thing. And I actually, instead of using O and H, let me put X, Y, and Z. So there's X, there's Y, there's Z. So if I do the cosine of theta, you agree it's x over y. And the cosine of 90 minus theta is x over y. So it truly is. This is another little relationship we touched on in geometry. Now, let's talk about the tangent of theta. The tangent's co-function is the cotangent. And the secant's, the secant's co-function is the cosecant. You see how they get their names now, I hope. Alrighty, so let's look at how we're going to use this. Example 3. Find a cofunction with the same value. Alright, so what is the cofunction of sine? Cosine, right? Cofunction, cosine, sine. 90 minus 46 is cosine of 44. So the sine of 46 is the same as the cosine of 44. Alright? What if I ask you to do the cotangent of pi over 12? What is the cofunction of the cotangent? The tangent. Now, I want to do 90 minus, but does it make sense to do 90 if I'm dealing with radians? Instead of 90, what is 90 degrees in radians? Pi over 2 minus pi over 12. Now, again, fractions don't scare me, so I'm going to go ahead and get a common denominator of 12. So I get 6/12 pi minus pi over 12, and it would be the tangent of 5 pi over 12 is the same as the cotangent of pi over 12. Okay, so if you'd like to go back up here in your formulas and go ahead and say, or cosine pi over 2 minus theta. If you need that, some of you will understand that 90 is, they're interchangeable, but if it helps you to write it down, go ahead and write it down. Alright, so I'm going to end the video tonight leading you up to word problems that we'll tackle in class tomorrow. So the last thing we're going to do is draw yourself a nice large right triangle, and we're going to label certain parts of him. Okay? This bottom angle we're going to call the angle of elevation. Now the angle of depression is actually not in our triangle. So, I have two parallel lines, the ground and the horizon, let's say. The angle of depression is out here. Alright, and I'm going to just give you some cluing words. So, for this piece, words that are going to mean to put it on there is when you see horizontal, base. This piece is going to be when we see height, altitude, vertical, we're going to use this slanted slide anytime we're talking about ladders, kite strings, line of sight, I'm going to add down here at the bottom would be shadows, And if we need to, we can add more as we come up with them, but at least this is a good starting point. So we'll pick up word problems tomorrow in class, and don't forget to do a couple of the practice problems, and I'll see you tomorrow.